Today we're going to continue with section 2.2 of energy applications, looking at alternative fuels and advanced technology vehicles. As we continue with our investigation into the various types of alternative fuels and vehicles, today we're going to look at hydrogen being harnessed for fuel cell cars, natural gas being used as fuel for natural gas vehicles, and propane being used as fuel in propane vehicles. In this presentation, I'm going to provide you with a variety of benefits as well as considerations to make when selecting which of these alternative fuels to use, as well as where these fueling stations are located across the United States and which types of vehicles that can or are already using this alternative fuel technology. Let's begin by looking at hydrogen. Hydrogen is abundant in our environment. It's stored in water, hydrocarbons, and other organic matter. One of the challenges of using hydrogen as a fuel comes from being able to efficiently extract it from these compounds. Currently, steam reforming, combining high temperature steam with natural gas to extract hydrogen, accounts for the majority of the hydrogen produced in the United States. Hydrogen can also be produced from water through electrolysis. This is more energy intensive, but can be done using renewable energy, such as wind or solar, in order to avoid the harmful emissions associated with other kinds of energy production. Almost all the hydrogen produced in the United States each year is used for refining petroleum, treating metals, producing fertilizer, as well as processing foods. Although the production of hydrogen may generate emissions affecting air quality, depending on the source, a fuel cell electric vehicle running on hydrogen emits only water vapor and warm air as exhaust and is considered a zero-emission vehicle. Major research and development efforts are aimed at making these vehicles and their infrastructure practical for widespread use. Although the market for hydrogen as a transportation fuel is in its infancy, the government and industries are working toward clean, economical, and safe hydrogen production and distribution for widespread use in fuel cell electric vehicles. This has led to the initial rollout of light-duty production vehicles to retail consumers in northern and southern California and fleet availability in northeastern states. The market is also developing for buses, material handling equipment such as forklifts, ground support equipment, medium and heavy duty trucks, marine vessels, and stationary applications. The interest in hydrogen as an alternative transportation fuel stems from its ability to power fuel cells and zero-emission fuel cell electric vehicles, its potential for domestic production, its fast filling time, and the fuel's high efficiency. In fact, a fuel cell coupled with an electric motor is 2 to 3 times more efficient than an internal combustion engine running on gasoline. Hydrogen can also serve as a fuel for internal combustion engines, but these produce tailpipe emissions and are considered less efficient. The energy in 2.2 pounds of hydrogen gas is about the same as the energy in 1 gallon of gasoline. Because hydrogen has a low volumetric energy density, it is stored on board a vehicle as compressed gas to achieve the driving range of conventional vehicles. Most current applications use high-pressure tanks capable of storing hydrogen at either 5,000 or 10,000 pounds per square inch. Retail dispensers, which are mostly co-located at gasoline stations, can fill these tanks in roughly 5 minutes. Other storage technologies are under development, including the use of graphite nanofibers, which we'll look into further detail next week. Let's go ahead and look at hydrogen in terms of its benefits and challenges. Starting with its benefits, hydrogen can be produced domestically, reducing our dependence on oil imports. It is considered environmentally friendly since fuel cell vehicles produce no air pollutants or greenhouse gases, and burning hydrogen in internal combustion machines produce only nitrogen oxides. Some challenges of using hydrogen include its availability. Hydrogen is only available at a limited number of public stations, mostly in California. However, more fueling stations are planned for the future. Fuel cell vehicles cost more than conventional vehicles, but the costs are decreasing as our technology improves, and there are also federal and local incentives that can be used to help decrease that cost. Still, only a few models are currently available for sale or for lease for the public. There's also the issue of onboard fuel storage. Since hydrogen contains much less energy per volume than gasoline or diesel, this makes it very difficult to store enough hydrogen on board as a fuel cell vehicle to go as far as a comparable gasoline vehicle between fill-ups. The increased number of retail hydrogen fueling locations in select markets is supporting the initial rollout of fuel cell electric vehicles. Mobile hydrogen fuelers, where liquefied or compressed hydrogen and dispensing equipment is stored on board a trailer, are also being developed to support the expansion of hydrogen infrastructure. These efforts are giving early fuel cell electric vehicle adopters confidence that they can drive normally and have access to the hydrogen fuel wherever they go within these regions. Take a moment and use the link provided to find the hydrogen fueling stations found across the United States. Vehicle manufacturers are only offering fuel cell vehicles to consumers who live in regions where the hydrogen stations currently exist. As of now, manufacturers including Honda, Hyundai, and Toyota are currently offering production of fuel cell electric vehicles for lease or for sale to customers in markets where hydrogen fuel is readily available, again, primarily in California. Efforts are also underway to expand hydrogen fueling locations in Hawaii and across the East Coast, with other markets expected to develop as consumer demand begins to increase. Hydrogen infrastructure is also developing for buses, medium-duty fleets, and material handling equipment. As we continue on with next week, we'll go into greater detail about how the fuel cell actually works. Let's go ahead and take a look at natural gas. Natural gas is a fossil fuel composed of mostly methane, and it's one of the cleanest burning alternative fuels, and it can be used in the form of compressed natural gas or liquefied natural gas to fuel cars and trucks. Compressed natural gas is produced by compressing natural gas to less than 1% of its volume at standard atmospheric pressure. To provide adequate driving range, compressed natural gas is stored on board a vehicle in a compressed gaseous state at a pressure of up to 3,600 pounds per square inch. Compressed natural gas is used in light, medium, and heavy-duty applications. A compressed natural gas powered vehicle gets the same fuel economy as a conventional gasoline vehicle. With liquefied natural gas, it's a natural gas that's in liquid form. Liquid natural gas is produced by purifying natural gas and supercooling it to negative 260 degrees Fahrenheit to turn it into a liquid. During the process known as liquefaction, natural gas is cooled below its boiling point, removing most of the extraneous compounds found in the fuel. The remaining natural gas is primarily methane with small amounts of other hydrocarbons. Because of liquefied natural gas's relatively high production cost, as well as the need to store it in expensive cryogenic tanks, the fuel's widespread use in commercial applications has been limited. Liquefied natural gas must be kept at cold temperatures and is stored in double-walled, vacuum-insulated pressure vessels. Liquid natural gas is suitable for trucks that require longer ranges because liquid is denser than gas and therefore more energy can be stored by volume. Liquid natural gas is typically used in medium and heavy-duty vehicles. Dedicated natural gas vehicles are designed to run on natural gas only, while biofuel vehicles can run on gasoline or diesel. Biofuel vehicles allow users to take advantage of the widespread availability of gasoline or diesel, but use a cleaner, more economical alternative when natural gas is available. Since natural gas is stored in high-pressure fuel tanks, biofuel vehicles require two separate fueling systems, which take up passenger and cargo space. Natural gas vehicles are not available on a large scale in the U.S. Only a few models are currently offered for sale. However, conventional gasoline and diesel vehicles can be retrofitted for compressed natural gas. Whether produced via conventional or renewable methods, the advantages of natural gas as an alternative fuel include its domestic availability, established distribution network, relatively low cost, and has emissions benefits. Renewable natural gas and conventional natural gas must be compressed or liquefied for use in vehicles. Like any alternative fuel, there are some considerations to take into account when contemplating the use of natural gas. Natural gas vehicles are similar to gasoline or diesel vehicles with regard to power, acceleration, and cruising speed, but they are less expensive. The driving range of these vehicles is generally less than the comparable gasoline and diesel vehicles because with natural gas, less overall energy content can be stored in the same size tank. Extra natural gas storage tanks or the use of liquefied natural gas can help increase the range for larger vehicles. All new vehicles are equipped with effective emission control systems and must meet the same emission standards regardless of the fuel type. As a consequence, tailpipe emissions from natural gas vehicles are comparable to those of gasoline and diesel vehicles equipped with modern emissions controls. In addition, because compressed natural gas fuel systems are completely sealed, the vehicles produce no evaporative emissions. Although the United States has an extensive natural gas distribution system in place, vehicle fueling infrastructure is limited. For this reason, many fleets choose to install their own natural gas fueling infrastructures, which can be costly, or they decide to partner with other fleets to establish shared infrastructure. Since vehicle fueling infrastructure is limited, so is the number of natural gas vehicles that are available. As of 2020, nearly 1,000 public compressed natural gas fueling stations are available in the United States. Approximately 70 liquefied natural gas fueling stations are also available, mostly in areas that service the long-haul trucking industries. For consumers, fueling natural gas vehicles at home can be possible with the help of a small fueling appliance. To find where natural gas, including both compressed natural gas as well as liquid natural gas, fueling stations are located around the United States, take a minute or two to select this link on natural gas fueling station locations. Natural gas powers more than 175,000 vehicles in the U.S. alone and roughly 23 million vehicles worldwide. Natural gas vehicles are good choices for high mileage, centrally fueled fleets because they can provide similar fuel range support for applications not involved in long-haul routes where fuel stations can become sparse. For vehicles that travel long distances, liquefied natural gas offers a greater energy density than compressed natural gas, meaning the fuel range is more comparable to the conventional fuel. Light, medium, and heavy-duty natural gas vehicles are available from original equipment manufacturers as well as medium and heavy-duty vehicle options available through qualified system retrofitters. Qualified system retrofitters can also economically, safely, and reliably convert many vehicles for natural gas operation with aftermarket conversion systems. And finally, let's look at propane. Propane is also known as liquefied petroleum gas, and it's a clean-burning alternative fuel that's been used for decades to power light, medium, and heavy-duty propane vehicles. Propane is stored under pressure inside a tank as a colorless, odorless liquid. As pressure is released, the liquid propane vaporizes and turns it into gas that is used in combustion. Propane has a high octane rating, making it an excellent choice for spark-ignited internal combustion engines. If spilled or released from a vehicle, it presents no threat to soil, surface water, or groundwater. Propane is produced as a byproduct of natural gas processing and crude oil refining. Interest in propane as an alternative transportation fuel stems from its domestic availability, high energy density, clean burning qualities, and its relatively low cost. It is the world's third most common transportation fuel behind gasoline and diesel. For vehicle fueling, the quick-release Type K15 dispenser connector is required to be installed on all new vehicles beginning January 1st of 2020, per the National Fire Protection Association Code 58. This connector allows for one-handed fueling and does not require the use of personal protective equipment such as gloves and a face shield, which are required for the older style connector. Propane is stored on board a vehicle in a tank pressurized to about 150 pounds per square inch, about twice the pressure of an inflated truck tire. Under this pressure, propane becomes a liquid with an energy density 270 times greater than its gaseous form. Propane has a higher octane rating than gasoline, so again, it can be used with a higher engine compression ratios and is more resistant to engine knocking. However, it is a lower British thermal unit rating than gasoline, so it takes more fuel by volume to drive the same distance. Let's go ahead and look at some of the advantages and disadvantages to using propane. As I said before, propane is a clean burning fossil fuel that can be used in internal combustion engines. Most of the propane used in the United States is produced domestically. It is usually cheaper than gasoline and does not degrade performance. Petroleum-fueled vehicles can also emit lower amounts of some air pollutants and greenhouse gases, depending on its vehicle type, calibration, and drive cycle. The drawbacks to using a petroleum-fueled vehicle are the limited number of fueling stations and vehicles. Over 900 public fueling stations actually sell petroleum fuel. A few light-duty vehicles, mostly larger trucks and vans, can be ordered from a dealer with a prep-ready engine package and converted to use propane. Consumers can also convert in-use conventional vehicles for propane use. Some propane use vehicles run on propane only. Others can switch between propane and conventional fuel, such as gasoline. Propane is stored as a liquid in pressurized fuel tanks rated to 300 psi. So propane fuel conversions consist of installing a separate fuel system if the vehicle will use both conventional fuel and propane, or as a replacement fuel system for propane-only operations. Converting a vehicle to use propane can cost $6,000 to over $12,000. However, this cost may be recovered in lower fuel and maintenance costs over the long term. There are over thousands of propane fueling stations found around the United States. Take a few minutes to go through this link to see where propane fueling stations are found. According to the Propane Education and Research Council, there are nearly 200,000 on-road propane vehicles with certified fuel systems in the United States. Many are used in fleet applications such as school buses, shuttles, and police vehicles. Propane vehicles are also available from original equipment manufacturers or can be changed by conversion.